Hello, all the cool peeps. This is me, Aryan Kumar, and today we are going to study about dimensions. Now, I have already explained how to form a dimension. You can find that thing on my channel, but we haven't studied what actually a dimension is, how to utilize that in a physical quantity or any type of like quantity, quality. Let's just first of all understand what actually it is. Dimension. You might have a certain idea what dimension is. You live in a 3D dimension. This pen in front of you is in a 3D dimension. Me as a human in front of you is in a 3D dimension. But the fun fact is, everything you see in front of you, whether it's chair, whether it's fan, whether it's anything, laptop, mobile phone, it is in a third dimension because you are in a third dimension and space itself is in a third dimension. And if you talk about all the relativity stuff, fourth dimension and all, there is a separate topic. We will focus upon that maybe in upcoming few days. Anyways, what is dimension? But before that, we need to focus upon few problems such as physical quantities and measurements, as this is an important part of our chapter as well. The chapter is measurements. So just imagine if there is an old person, okay, that weighs 70 kg and he wants to climb, or you can say walk throughout the 10 steps of the stairs, and the height of that staircase is 3 meter per stair. Now just try to calculate it. Now of course, if he'll move upwards, he will need energy from his body. Okay, now don't get confused between force and energy. Force will be initially applied by him, but the energy is the main cause by which the foam is being, not foam, it is force is being applied. Now the formula for energy is mgh, that is mass per gravity per height. So the given mass multiplied by the number of that object that is he climbing, basically the distance, and the height or the size that is being defined in the question. We will just add that up and answer our question at the point. Now, this was the first ever example of a physical quantities and measurement. You can again check it out, you can try to understand it by yourself as well. Okay, now let's just focus upon what are derived units. Okay, before dimensions, we need to clear these topics because these are somewhat necessary topics for us. Now, in grade 9, just remember a thing. You might have studied what are units, what are base units, such as kg, um, like Newton, maybe for time it was S, for force it was, um, and for mass it was maybe kg, uh, mass it was gram. There are a lot of units, right? We have already studied that. But what are the derived physical quantities and also their units? How to write this in a short form? Basically, if I'm giving you any long formula, such as, not a long, we have example of short formula here. I can provide you a maybe example of gravitational force. You can just consider that in your mind and try to solve it. Basically, mental physics or mental maths. So just focus upon this at first, then you can do whatever you have to do with any formula. If force is equal to mass and mass is into the acceleration, the, we have to calculate the we have to bring the value of acceleration as well, and acceleration equals to velocity upon time, or you can say displacement upon time. Okay, so if I have to write this whole thing, whole stuff in a short form, how will I do that? You can simply see right here. Now if we put SI unit for each quantity, for example N for force, kg for mass, and M for displacement, and S for time, so we get N is equal to kg multiplied by meter per second square. That was very simple. You can now imagine any formula in your head and just try to solve it. by using a paper and a pen, or even mental maths work at this point, because you have to deal with MCQs, OMR sheets in future. Okay, now let's just dive up to what are dimensions. As I just told you right now, this is all about qualitative and quantitative quality. You can just call quantity as somewhat that measures any mass, or quality somewhat that measures any volume. That is somewhat a easy definition for it. Okay, for example, for qualitative, now dimension deals or denotes itself always with a qualitative nature. Okay, so for example, length into not into sorry, length, width, height, or distance or displacement or radius is example of it. Okay, you can consider any example, anything else such as velocity, that can be example as well. So these are few qualitative examples for a dimension, and these all are measured in only one SI unit, that is meter. That is cool and interesting as well. Now they are having the same nature, that's why they are called qualitative quantity or qualitative quantity in our nature. So we have to utilize the same nature of formulas in our brackets, in our MLT, that is mass, length, and time structure that we have already studied. You can again find that video on my channel. You can just search through dimensions on my channel as well. Now, what are dimensions? What are dimensional variables? Now, those physical quantities that have dimension and have variable magnitude are called dimension variables. Some dimensionless variables are length, velocity, acceleration, force, energy, and acceleration. Okay, if I give you an example of, I can say acceleration maybe. Yep. Let me just open a PDF, basically a blank page. Okay. So you can just simply say that acceleration equals to displacement upon time. Is that so? Now, these all words, or you can say vocabularical formulas, are being formed here by a variable. A variable is acceleration. Therefore, displacement and time are its quantities. That's what a dimensional variable is known about. That was simple, right? And if I talk about dimensional constant, now those physical quantities that have dimension constant in magnitude are called dimensional constant. Some example of constants are, now let's just focus upon constants. There are Planck's constant, gravitational constant, speed of light in vacuum and ideal gases. Let me just explain this whole scenario in very simple words. Now, if I have anything that have like magnitude, okay, that are at a constant thing and meanwhile having a magnitude, are called a constant um, dimension, such as um, K, and the formula for resistance. If the resistance is constant, then the whole dimension will be, first of all, uh, a magnitude, and it will be calculated as a dimensional. Okay, it will be calculated as a dimensional constant, not as a dimensional variable. So please try to remember that thing in your mind. Now, what are advantages of dimensions? You can just simply read that and try to amplify. I will just explain the homogeneity of an equation. You can stop the video, read the advantages, because I believe that isn't important to understand yet. It is initial, it is good, that is not bad for studying. You can increase your knowledge by studying anything. So you can go through it. Now let's just discuss what is homogeneity. If I say when a dimension MLT is equals to MLT. Again, that is known as a homogeneity, law of homogeneity. Nothing more complicated or difficult here. You can just call it as a LHS equals to RHS, and that's it. You don't want to just understand it, but you can just clarify your mind that it is LHS to RHS. That means left hand side to right hand side. It also means the same term that is being used on the right or the left side, and again on the other hand of it. That's it. And thank you for joining on my channel today throughout my journey. This was all about this lecture. I hope you liked it. Again, leave a um, like, drop a comment, and that's it.